Hello, we are back continuing to go over those May 2025 IB Chemistry TZ2 IB exams. And so we are continuing on with questions number 11 through 15. We're doing it in sets of five, if you haven't noticed, just to not make the videos a million years long because they're already pretty long. Anyway, so number 11, this has to do with monomers and polymers, which for some reason students struggle with. And so these questions are super easy if you know how to approach them. And so it says, which monomer produces this addition polymer? And so normally you should remember that, I mean, especially for SL, but SL and HL, actually, you only know one kind of addition polymer, and that's going from alkene to alkane. And so your monomer should have an alkene. If you forget this, if you look at your options, all your options have alkanes. Crazy, right? And so if you look at your options, is they have to resemble your polymer, right? And so your polymer has this, you have your two main carbons, right? And so within your two main carbons, you have one that has a CH3 and then H, and then one that just has two H's. Okay, so carbon one has CH3 and H, and then carbon 2 has just H and H. Okay. And so whenever you are looking at your monomer, is the only difference is rather than having these weird, I call them carbon to air bonds. I don't really know why. Rather than having these weird carbon to air bonds, you do not have those anymore. And you just have a double bond instead. Okay. So you should have a structure that looks like this. And so whenever you're looking at your answers, so like option A is option A has on carbon one a CH3 and an H, looking good. Your carbon two also has a CH3 and an H. You don't have two of them, so that one is incorrect. For option B is your main carbon has a CH2 CH3. That's already wrong, so that's wrong. Your option C is you have your carbon one has an H and an H, looking good. Carbon two, an H and a CH3, also looking good. So option C is right, but we're going to check D just to be safe. So option D is you have on your carbon one an H and H, looking good. On your carbon two, you have a CHCH2. You have two alkenes for some reason. That is disgusting. That's gross, and that is not right. So the right answer here is C. Okay, and so continuing on, we have question 12, which question 12 is actually one that whenever I took this exam myself, under simulated conditions, the timing is I actually put a star by this, and then I continued my exam, and I came back to it because I was like, I just wasn't sure, right? And so I feel like it's kind of difficult. It's not really shown up before. And so it's why do group 17 elements have higher first ionization energies than group 1 elements in the same period? And so at a glance, this looks like the type of question where it asks you about the ionization energy exceptions. However, this is not the case. It's literally just 1 versus 17. So this is the general first ionization trend, not the HL content. Okay. And so it is group 17 versus group 1. And so there's two parts of this question, which is first is it has to be a true statement. And then the second is it has to explain why. These types of questions tend to trip students up because they choose only the one that's correct, not the one that is why. And so it's also another reason why I always emphasize looking through all the answer choices. Once you've chosen one, like even if you think A is right, look at B, C, and D, because if you have two that are correct, then you should think, oh, it's Y, not just correct. Okay. And so in this case is you have option A, which says that group 17 elements have more electrons in the valence shell. This is true because their valence shell, regardless of what period you're in, is they have the P versus the S. So they have P, and so they have more. Okay. And so this one is, I'm just going to put kind of correct, but not circle it because that doesn't necessarily mean explains why. Right. And so B group 17 elements have more filled energy levels. And so since this says that they're in the same period, that one is not true. And therefore it also can't be Y because it's not true even in the first place. Okay. So that one is not true because they have the same shielding because they're in the same period. Okay. So they have the same shielding, they're in the same period. So B is not right. C, group 17 elements have more paired electrons. And so that is one where you have group 1 versus group 17. And so, like 17, you would have, so like you'd have, I'm just going to use period 2 as an example. So, like in the period 2, is you'd have your 2s, which would just be your 1, versus for 17, you'd have 2s, 2p. There we go. No, wait. I wrote that down wrong. But 1, 2, 3, 4, 5. There we go. So it'd be 2p5. And so whenever you look at this, so this would be 17 versus group 1. And so they both have the same number of unpaired electrons. So that one is not true. See. And then D finally, as group 17 elements have more protons in the nucleus as they have an increasing atomic number. So 17 has more atomic number. It does have more protons in the nucleus. So this one is correct. So this brings us to A versus D. And that's where I stopped and put a star and I moved on because I didn't want to think about it too much and I just wanted to come back to it. So whenever I came back to it, here was my thought process is I was thinking where it's saying why, right? And so there's a common paper 2 type question, which you should be familiar with because it comes up all the time, is it's kind of explain the trend in the ionization energy from group blank to blank, whatever, and it's just increasing, right? And so there's always 2 marks in these types of questions. Is it's always same shielding, and then it's also not same. Is it is increasing nuclear charge. Okay, nuclear charge. And so a lot of students, they memorize this, they write it down all the time, they get it right, but they're not really sure what nuclear charge is. Okay, and so nuclear charge isn't about the number of electrons, it's the number of protons, it's the increasing atomic number. That's just what that is. And so that is why D is the correct answer. And in addition, whenever you're thinking about why A is also not Y, it's because the first ionization energy is ionizing one single electron. Okay, is one single electron. And so even though you have more electrons in the valence shell, that doesn't matter. This isn't about the successive ionization energies. This is just about one electron. It doesn't matter if there's more in the shell. As long as there's one, that's the only thing that really matters right now. Okay, it's for that first ionization energy. And then for D, because it's how attracted that one electron is to the nucleus. And so if the nucleus has more positive charge, it's like, no, don't go. No, don't go. You're so sexy, is that increasing positive charge increases that attraction and therefore makes it harder to ionize. Okay. And so that is why group 17 has higher because it takes more energy because there's more protons in the nucleus, more no, don't go. More attraction, harder to ionize. Okay, so that is why. It's all about the why here, not just which is correct. Okay, and so D is the right answer for number 12. Okay, and so continuing on with question number 13, this is about which part of the periodic table contains elements which are likely to form acidic oxides only. And so this is about acid and basic oxides, as well as that kind of periodic trend that is associated with it. And so with this, there are 2 things that you can get rid of immediately. And so the first is D, which D is the lanthanides. Okay, and so D, the only thing we learn about the lanthanides is that they're a black F and that's it. That's what they're called. That's literally all that we learned. And so that's not going to be your right answer. B, your transition metals. Transition metals, a lot of the content is HL only. And also what we learn about transition metals is the fact that they can basically do whatever they want. They can form various oxidation states. They have lots of various properties. They're not as much predictable as the rest of the periodic table. Like in all the periodic table trends, as we look at like period 1, period 2, and then we're like, ignore the transition metals because they are weird. So they're not going to really go with this trend. So that leaves us with A and C. A is your metals, and then C is your non-metals. So first I'm going to first tell you the trend, then I'm going to explain the trend, because I feel like that helps you remember it, right? So that you can reason it out yourself during the exam if you forget, right? And so your metals, these are things like sodium, magnesium, barium, and so they form oxides like the sodium oxide, magnesium oxide, and barium oxide. And so whenever you're considering whether an oxide is acidic or basic, is you have to think about the reaction with water. And so like Na2O plus water is going to form sodium hydroxide. Okay. And so I'm too lazy actually to balance this, but it's going to form sodium hydroxide, I swear. Let me, so, 1, 2, 1, 2, 1, 2. Okay, that's balanced. There we go. So it's going to form sodium hydroxide. Sodium hydroxide is basic. So these metal oxides are basics. There we go. And so that's kind of how you should remember it. The same thing applies with nonmetals. Nonmetals, you have things like SO2, CO2, so on and so forth. And so when they are in water, is they are going to literally just form things like H2, SO3, H2, CO3. So these types of acids. So they're going to form acids, therefore nonmetals form acidic oxides. Okay. Metals form basic oxides. If you remember this trend, you can solve this question faster. But if you don't remember this trend, once again, always try and derive the information. Okay, is always try and remember why that you can derive it. So the answer to this question would be C, because that would be your non-metal oxides forming the acidic oxides. So continuing on with question number 14. Question number 14 is about the oxidation state of nitrogen in this N2O4. And so I like to solve oxidation state questions just like hello, Val. Like math problems. She's talking. She wants to explain as well. And so we have this N2O4, and so oxygen is going to have an oxidation state always, unless it's a peroxide of -2. And so also you can remember this, similar to the periodic table trends for the monoatomic ions. So -1, -2, oxygen. Crazy. And so I like to do this. So you have 2 nitrogens, and you have 4 oxygens. So you have +4. They all have a -2 oxidation state. The overall oxidation state of this compound needs to be 0 because it's neutral. If this were an ion, it would be whatever the charge of that ion was. Okay, so you have 2n minus 8 is equal to 0. So then you get 2n is equal to +8, and n is then equal to +4. Cool. So +4 makes this answer D. Okay. So you may be tempted also to be like, for this question, you got -2 from the periodic table. Well, why not go like nitrogen is -3, right? Like, why not just do that? Well, one, it's not an option. So there's that. But then two, you kind of, I don't know, oxygen and hydrogen, those are the two that you can pretty much always get from the periodic table, and always their oxidation state is always the same. All the other compounds, they tend to vary a lot more. So I just kind of use that as a rule, is always do those ones first. Cool. And that is number 14. Okay, and so question 15. Question 15 is talking about the properties that are typical of transition elements. And so whenever I was taking it myself, I was like, low melting points. And I was like, are they? And so I put a question mark there. And I remembered we have the data booklet. Oh my God, crazy. You can fact check with the data booklet. It's very useful. And so I went over here and I went over to the melting points and the boiling points of elements. And I went and I kind of looked at the transition metals, which kind of have, you see the melting points on top. So that's like 1, 2, 4, 6, 1, 5, 3, 8. Then I'm like, okay, what constitutes low? And so I looked at the other elements and I was like, okay, we have stuff in the negatives. And whenever I think of as well, like melting points, I also tend to think of like the low melting point element that we think of a lot is gallium. Okay, and so I went and I looked at gallium, and I was like, oh, gallium is 29.77. Some of these as a reference. These guys are not close, so they're not low. They do not have low melting points. And so I put that as no. Okay, which is true. Ended up being true. And so, two, formation of colored compounds. That is correct. It's a common thing they ask about with transition elements because of the fact that they are able to have their d orbitals that can be split, and that energy gap can absorb visible light and then emit the complementary color. Very important thing. So that is correct. For three variable oxidation states, they have really close successive ionization energies. This is straight from the subject guide. You need to know this, including the why, is they have really close ionization energies. which allows them to go in between various oxidation states very easily. And so that is also true. And so this answer is 2 and 3 only, which is C for number 15.